Okay, section 10.4, use inscribed angles and polygons. First, some vocabulary. An inscribed angle is an angle whose vertex is on a circle and whose sides contain the chords of the circle. That is an awesome circle. So I'm going to draw an angle. So an inscribed angle, the vertex is on the circle, and the sides are the chords of the circle. So that is an inscribed angle. Intercepted arc is the arc that lies on the interior of the inscribed angle and has endpoints on the angle. So Theorem 10.7, measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So you can say the angle is 1/2 the arc. Okay? Example 1, find the indicated measure in circle P. First we're going to do the measure of angle T, right there. So we said the angle is 1/2 the arc. So angle T is 1/2 of 48, or 24. And then B, the measure of arc QT. The angle is 1/2 the arc. Angle, 1/2 arc, times 2, times 2. The arc is 100 degrees. Find the measure of arc RS and the measure of angle STR. What do you notice about STR and RUS? So here we're given the inscribed angle. They're asking us what the intercepted arc measurement is. So we just said that angle is 1/2 the arc. We know the angle is 31. 1/2. We don't know what the arc is. Times 2, times 2. The arc is 62. That is the measure of arc RS, which is right there. The cool thing is arc RS has an inscribed angle RUS and STR. So angle RUS is congruent to angle STR. Let me erase all that stuff so we can see it. Which is neat. That means that angle STR and RUS are both 31 degrees. See that? So this intercepted arc has two inscribed angles. That angle and that angle. That means those angles are congruent or equal. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. That's just what we proved. So I have an intercepted arc and two inscribed angles here, an intercepted arc, two inscribed angles, which is pretty cool. You just have to see them. If they have the same intercepted arc, then the inscribed angles are congruent. Name two pairs of congruent angles in the figure. What I find is just to go through the multiple choice and eliminate them. Sometimes it's easier. So let's look at A. I have angle JKM and angle KJL. Those don't have the same intercepted arc. They have different intercepted arcs. That had this arc and that arc. So we don't want to use that one. A is eliminated. B. JLM, JLM, and KJL. KJL. That was that inscribed angle and that inscribed angle. So that doesn't work. So we're eliminating B. Let's try C. JKM, JKM, and JLM. That was that arc. KJL, KJL, and KML. It's that arc. I think we have a winner. Find the measure of the red arc or angle. So they're asking for the red arc here, right there, and we see that, angle, the red angle. The angle is 1/2 the arc, 1/2 of 90. Oh, this is a U-try, bummer. The angle is 45 degrees. The next you try, angle 1/2 arc. Okay, we don't know the arc, we know the angle. We can get rid of that 1/2 by multiplying both sides by 2. So 2 times 38, 16, 676 is the measurement of the arc. Alright, find the measure of the red arc or angle. Crazy thing here is they've given us this angle and they want that one. But look, it has the same arc. If it shares the same arc, that means those angles are congruent. So I can't read it anymore. Angle ZXM is congruent to angle ZYM. So they are both 72 degrees. Right, a polygon is an inscribed polygon if all of its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. So I have an inscribed triangle, inscribed quadrilateral, and the circle is circumscribed. New theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So if you ever have a right triangle inscribed in a circle, the hypotenuse is always going to be the diameter, and the right angle will always be on the circle. Let's try to use this. Your camera has a 90-degree field of vision, and you want to photograph the front of a statue. You move to a spot where the statue is the only thing captured in your picture as shown. You want to change your position. Where else can you stand so the statue is perfectly framed this way? Okay, we just learned if it's a right triangle, then the hypotenuse is the diameter. So if we know the diameter is, we know half of that is a radius. Okay, we can measure and draw a circle. If you stand anywhere on that semicircle, let me erase a piece of that radius. Anywhere on that semicircle, you're going to be, your statue is going to be perfectly framed because you're going to be on the semicircle, which would be a 90-degree angle because the diameter is the hypotenuse of your right triangle. So anywhere in that semicircle is where you can stand. Well, which is that picture right there. Awesome. What if, in example 4, explained how to find locations if you want to frame the front and left side of the statue in your picture? Okay. With this one, it's the same. I mean, if you're going to stand over here, that's going to be your diameter. So that's a terrible drawing. Okay, diameter being your hypotenuse, so half of that. If you just measure out the radius, that'll give you a semicircle. on all sides. So as long as you stand anywhere on that semicircle. It looks like an ice cream cone. Blueberry. Inscribed quadrilateral. Only certain quadrilaterals can be inscribed in a circle. Theorem 1010 describes these quadrilaterals. So quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So the angles opposite each other have to add to 180. So in our examples, we're just going to take the opposite and set up a supplementary equation. So if we're finding the variable, we know that 80 plus x equals 180. Subtract 80 from both sides, x equals 100. Same with the red. 75 plus y equals 180. Subtract 75 from both sides. Pretty cool. And they'll just get a little bit harder. Okay, find your opposite sides and set up an algebra problem. 2a plus 2a equals 180. 4a equals 180. A equals 45. Or 4b plus 2b. 4b plus 2b equals 6b. Divide by 6. Pretty simple. Okay, you try. Push pause. There we go. One more. Okay, set up your problems and solve for your variables. There we go. Daily homework quiz. I think I have about 4 sheets, I think 4 problems, 2 points. Turn it in tomorrow. Here's number 1, 2, 3, 4, one more after this, 5. Good job today.